In the second demo problem, we must algebraically form a linear program from the following verbal description. In this problem, an auto company wants to minimize their transportation cost for cars from production plants to distribution centers while satisfying supply and demand restrictions. It is usually a good idea to start formulating optimization problems by asking what question are we trying to answer. For example, in this problem, our question is how many cars to ship from plants E to distribution centers J to minimize transportation costs while satisfying supply and demand restrictions. We might also want to graphically visualize the problem as seen in this graph. The next step is to list the parameters related to the problem. For example, we have the capacity of the plant E, the demand from distribution centers J, and the cost of transporting car from plant E to center J. And here we denote all elements of a set implicitly, for example, only using I instead of I belongs to the big I set. After listing the parameters, we should list the variables. Here we have the amount of cars shipped from plant E to center J, which is denoted using the notation X. And the universal quantifier here means that this constraint holds for all pairs IJ, as denoted this product set. Then we will move on to defining the constraints. So here we have total amount of cars shipped from plant E must not exceed its capacity, modeled by this expression. This means the total amount. This is the cars shipped, and from plant E, which is the I for every plant, and must not exceed, it's this one, and obviously the capacity is the A. Also, the total amount of cars shipped to a center J must satisfy its demand, and it's this expression here. It's the same thing. Total amount cars shipped, this center J, and must satisfy its demand. This is the demand, and obviously the cars shipped to this center must be more or equal to the demand. Finally, we define the objective function, which is to minimize the total transportation cost. And it is this expression. Here we have minimize, and this is the sum over the transportation cost times the amount of cars shipped and summed over all pairs IJ,